Hello guys, and welcome back to another video. On this video we'll be looking at another problem of making, or rather doing, stoichiometric calculations. Let's get right into it. So here they're saying to us nitrogen monoxide and carbon monoxide react according to the following balanced equation. This is our equation, and remember guys, when you do these calculations, it's important to confirm that the equation is balanced. But most of the time, if it is, they'll say so on the statement, and if they don't say that, then it means you have to balance the equation yourself. Another thing that you need to remember is that when you do these calculations, we'll be making use of what? Coefficients of our substances. That's why it's important for the equation to be balanced. All right, now let's proceed. They are saying here 50 grams of nitrogen monoxide reacts completely. Calculate A, the mass of carbon dioxide which is produced. Now check what's going on here guys. We are given the mass. I don't know if I should say mass or mass. Mass. The mass of NO2 in this case is equal to what? 50 grams. So the information that we have is that of NO2. And what are we looking for here? We are looking for the mass of carbon dioxide. So here we are looking for the mass of carbon. It's actually okay. We are looking for the mass of carbon dioxide. We do not know the mass of carbon dioxide, and this is it here. And if you notice, we have CO2 and CO carbon monoxide, CO2 carbon dioxide. So this is what we are focused on. I'm also gonna highlight this one here. Let me just highlight everything, in fact, including the ratio, the coefficient. So the two things I've highlighted are the ones that we are concerned about. They are the ones that we will be using to do our calculation for A. Let's get into it. So given that we have the mass of NO, or nitrogen monoxide, we are gonna have to firstly use this mass to find the number of moles of nitrogen monoxide. So that's what we're going to do. A, we will find the number of moles of nitrogen monoxide, or NO, and the formula we are using is small m over big M. We know the small m is the mass and the big M is the molar mass of what? Nitrogen monoxide. So our mass in this case for NO is 50 divided by the molar mass. What is the molar mass? The molar mass is going to be 14 plus 16. Where do we find this information, guys? We find it on our periodic table. Unfortunately, I can't show the periodic table, but the molar mass is that big number under your element symbol. Okay, it's that big number. There are three numbers, but in your case, you look at the number at the bottom, which is the bigger number than the one above. Bottom number. Okay, so now we are going to put all of this on the calculator for the sake of saving time. We'll say 50 divided by, let's see, 50 divided by 14 plus 16. And the answer that I'm getting is 1,66667. So I'm going to round off that answer to 1,67 mole. Let me just rewrite it. The answer is going to be 1,67 moles. After we have found this number of moles, guys, can you guess what the next step is going to be? Remember what I've said in terms of the previous video, the one before this one. I said the next step is to use these number of moles that we found of nitrogen monoxide to find the number of moles of carbon dioxide. Okay, we will use ratios, and then when we use our ratios, we will write our two substances in the form of ratios. So we'll say NO is to CO2, and I want you to notice that when we write our substances, we do not consider the coefficients of the two substances, because the coefficients of the substances we are going to write under the substances. So the coefficient of NO, which is the mole ratio, is what? 2 is 2. The coefficient of CO, 2 is what? It's also 2. Now, this is what I want you to know, guys. It's that when the coefficients or the mole ratios are the same, then it means that carbon dioxide will also have the same number of moles as those of NO. It means if these two numbers, the coefficients, are the same, then the substance without the number of moles will have the same number of moles as the other substance with the number of moles. But we can prove this by using a calculation. Makes you more comfortable and guarantees that your answer is correct. So we start by writing the substances in a form of ratios. Then we write the coefficients of the two substances, and then after the coefficients, what do we write? We write the moles of the two substances. We know that the number of moles of NO are 1,67 moles. We just found them, so I'm going to write 1,67 is 2. Do I know the number of moles of carbon dioxide? No, I do not. I do not know the number of moles of carbon dioxide. Then when I proceed, what am I going to do? When I proceed, I'm going to cross multiply. I'm going to cross multiply. So I'll say 2 multiplied by 2. 2 multiplied by n, and that's going to give me 2n. And then I'll say 2 multiplied by 1,67, and that's going to give me 3,34. And then I'll divide by 2 on both sides. And I've already said that because our coefficients are the same, I expect the number of moles of carbon dioxide to be equal to the number of moles of nitrogen monoxide. Let's see if the calculator will give us that answer. So here I'm gonna say n is equal to 3,34 divided by 2, and that gives me what? If I say 3,34 divided by 2, the answer I'm getting is 1,67. So here, guys, you can see that if your two substances have the same ratio or coefficients, then they will have the same number of moles. But you can use the calculation to really prove that that's going to be the case. So this is how we find the number of moles of carbon dioxide. But again, guys, we have to remember that the reason why we need the number of moles of carbon dioxide is because we need its mass, right? So we are not done. We need to continue with our calculation, because there's a formula that says n is equal to small m over big M. This is where we are going to get our mass. Okay, this is where we are going to get our mass. How are we doing that? We are going to substitute the number of moles of carbon dioxide, the one we found using ratios. So we will have 1,67 is equal to the mass of carbon dioxide. It's what we are looking for, right? Divided by the molar mass of carbon dioxide. So that's going to be 12 plus 2 multiplied by 16. Obviously here we are saying we have 1 carbon plus 2 oxygen atoms multiplied by the molar mass of carbon. If you don't know how to calculate the molar mass, guys, check my playlist. It does have a video on that shows you how to calculate the molar mass. And now we can proceed, guys. We'll proceed here. Let me just find the total of this. It's gonna be 1,67 is equal to the mass of carbon dioxide divided by 44. And then we can cross multiply here. We'll say m multiplied by 1, and that's going to give me m, which is the mass of what? Carbon dioxide, is equal to, and then I'll say 1,67 multiplied by 44, and this is going to give me an answer of 78 comma, just do the same. I'm gonna get an answer of 78,48 grams. That's the unit for our mass. I hope, guys, this is making sense. So that's how we deal with A. Okay, now let's go to B. Okay, guys, for B, they are saying we have to calculate the volume of nitrogen gas produced. So this means that we are no longer looking at nitrogen oxide and carbon dioxide. We are now looking at nitrogen oxide and nitrogen. Okay, but the information that we are going to use is information that we already have. Okay, let's remember that we had already found the, what did we find? We had already found the number of moles of nitrogen monoxide here on part A. And remember that the number of moles of nitrogen monoxide was equal to 1,67 moles. I hope, guys, you remember that. The number of moles of nitrogen monoxide was equal to 1,67 moles. So we are going to use these number of moles to find the number of moles of nitrogen using what? Ratios. And why are we using ratios, guys? Is because we cannot find the number of moles of nitrogen using the formula N is equal to small m over big M, because we do not have the mass of nitrogen. I hope that makes sense. And why are we looking for the number of moles? It's because they are saying here we have to calculate the volume of nitrogen gas produced calculated at STP. So this means we have to use the formula N is equal to V over Vm. But this formula, for us to find this volume, we need to have N, which is the number of moles of nitrogen. So we don't have them. That's why we are finding them using ratios. I hope you get that. So now let's use our ratios. Remember, I said that when we are using our ratios, we are going to, when we use our ratios, okay, let me write this up here. N of NO is equal to 1,67 moles. Okay, remember I said when we are using ratios, we are going to focus on the substance that has information and the one that doesn't have information. In this case, it's nitrogen for B. So we'll say NO is 2 and 2. And then after writing the substances in a form of ratios, what do? We write the coefficients of these two substances, right? The coefficient of NO is 2. The coefficient of nitrogen is what? It's 1, because there's no number here. So I'm going to write 1. And then the number of moles is what I'm going to write next. What is the number of moles of NO? It's 1,67. Is 2. What's the number of moles of nitrogen? And 2. We do not know. Then we will cross multiply here. Say 2 multiplied by N, and this is going to give us 2N. And then we'll say 1 multiplied by 1,67. We're still going to get 1,67. And then we divide by 2 on both sides. So our N is going to be what? Let's see. If I say 1,67 divided by 2, the answer I'm getting is 0,835. I can round off this to 0,84. But to be honest, guys, it's advisable that you do not round off your answer. You know, I'm actually wrong to round off early. Under normal circumstances, rounding off early is not advised. So maybe I should just write 0,835. But you can also say 834. I mean 0,84. That would still be okay. All right. So this is the number of moles I'm getting. And then from here now I can finally go to the next step, which is to find the volume of nitrogen, because now I have the number of moles. And remember, because I'm calculating at STP, I'm using the formula N is equal to V over Vm, Vm being the molar volume, and remember that this one is a constant. My N is 0.835 is equal to my V is what I'm looking for, the V of nitrogen, divided by the molar volume, which is 22.4, and then I cross multiply here, guys. Let's see, let me put this a bit up. So it's gonna be 0.835, then I'll divide it by 1, and then I'll cross multiply. I'll say V multiplied by 1, so the volume of nitrogen, even if you just write V, guys, that's okay. The reason why I'm putting N2 in brackets is because I want us to be aware that we are looking for the volume of nitrogen. So I'll say V is equal to, and then this side I'll say 0.835 multiplied by 22.4, and the answer I'm getting is 18.704. So I'll round it off to 18.70 dm cubed. I hope, guys, you get how this works. And yeah, like I always say, if maybe you didn't understand this, just play back the video. You guys also be kind in liking the video and also sharing it with your friends. Subscribe as well if you have not done so already. I'll see you on the next one. Bye.